the addition reactions. In addition reaction, we have done 4 examples. We have done 4 examples like addition of hydrogen cyanide, which has given us cyanohydrin. Then we have done the addition of sodium bisulfide to get bisulfate reduct. And we have found in bisulfate reaction that the products are reversible. If you treat the bisulfate reduct of aldehydes and ketones, to that if we add either dilute HCl or dilute sodium hydroxide, the compound decomposes to give us again back the pure aldehydes and ketones. Then we have done the reaction of the aldehydes and ketones with alcohols. Initially, both of them have produced hemiacetal or hemiketal, and again, so first step is addition reaction. In second step, another alcohol molecule substitutes the OH group, and you get acetal and ketal. But when you carry out this reaction with ethane 1,2-diol or ethylene glycol with ketone, then we get the cyclic acetals or cyclic ketone. After that, we have done a very important reaction is the addition of Grignard reagent, and we found this is the only method in which all the types of alcohols can be prepared, be primary, secondary, or tertiary. So if I react Grignard reagents with formaldehyde, then we get primary alcohol. For any aldehyde other than formaldehyde, then we get secondary alcohol. And if you react with any ketone, you get corresponding tertiary alcohol. So now, today I'll do another reaction. Initially, I'll not name it. First, I'll show you, then you yourself will tell me. See, we know that nitrogen has a lone pair. So, either this R can be H. If R is H, it is ammonia. Or it may be a derivative of ammonia. Okay? So, ammonia and or ammonia derivatives are strong nucleophile, but they are neutral. So, what it can happen? We will undergo addition. What you are going to get here? Right. So this is the addition product. But very interesting, we find such type of addition products is not stable. Okay. So in such case, what happens? Immediately a molecule of water goes out by itself. What you get here now? You get a compound like this. See, first step we know this is called addition. Addition reaction always gives you saturated molecule. Addition. And wherever a neutral molecule loses another neutral molecule, that process is called what?
Excuse me, sir. Sir, it's not that clear.
Wait, please wait. Yes, yes.
Excuse me, sir. Sir, it's not that clear.
See here. So this is first step is the addition reaction. Second step is the elimination reaction. Then what should you call this type of reactions? We call it addition, elimination. In your book, these examples are being given. but they did not mention the name of those reactions. Please remember, these are addition elimination reactions. Clear? So in your book, some of the examples are not given, but we'll do it. So first I'll write reaction with ammonia. See, when it is ammonia, R is equal to H. Okay, I'll not write R here. I'll write G here. G stands for group. So when I do the reaction with ammonia, G is equal to H. So what is going to happen? And I'm taking here formaldehyde. This is not in your syllabus. Okay? So I'll write like this. Okay? So what is going to happen? These reactions are very, very easy. Yeah? Closing your eyes also you can write. I'm not going to write the intermediate product. Straight the final product. So what I'll write now? Here, HCH. Okay. Plus water. All right. I told you carbon nitrogen bond, double bonds. This functional group is called imine. IMINE. So it is imine of what aldehyde? It is imine of formaldehyde. So we'll call it formaldehyde imine. See, this is an unsubstituted imine. Means what? Here nitrogen, hydrogen is there. If the nitrogen, hydrogen is being replaced by alkyl or aryl group, then we call it substituted imine. So this formaldehyde imine is not stable. Just like you are not stable without friend. All right. Without friend, the life is very, very boring, na? Like this. So what is going to happen now? You will find 4 molecules of this will react with 2 molecules of formaldehyde. So I'll write now here 4 molecules of formaldehyde imine. Formaldehyde imine reacts with 2 more molecules of formaldehyde. Okay? To give you a very interesting product. Okay? Don't get nervous by this. Looking at the product. You get this one. Okay? Plus 2H2O. This is the one. How does it look? Does it look like an exhaust fan? Huh? See here. What is the name of this one? IUPAC name is very difficult because it is tricyclic. Not tricyclic, tetracyclic. Forget about this. See, these are all CH2. All these H's come from here. 1, 2, 3, 4, 5, 6. So there are 6 CH2s are there. CH2 group is called methylene. So its name of this is called hexamethylene tetramine. It's called hexamethylene tetramine. It is very, very important compound. You know why? This compound is being used as a medicine to treat what? To treat urinary infection. Okay. Many a time we develop this urinary infection because using toilet which are not clean, and it causes severe temperature. All right. So this compound is being used for the excuse me,
So what is that hexamethylene?
tetramine. Tetramine. Hexamethylene tetramine. But when we use this as a medicine, his name is called urotropin. Okay, because medicine the names are being made simple. Otherwise, doctors will not be able to remember such big name. You when future also, when you will become a doctor, huh? If you are being asked what is the chemical composition of urotropin, you may tell, please get out. Okay, so this one is being used as a medicine, we call it urotropin. So I have given this one for your entrance exam. Now, if you go for the controlled nitration with concentrated nitric acid, then this compound undergoes nitration to make a very dangerous explosive. Okay, very dangerous explosive. Okay, so controlled nitration of hexamethylene tetramine. On controlled nitration, it gives us a very dangerous explosive. Okay, you'll find in our country also, this is the various places that terrorists are using it. Huh? It's called RDX. You heard the name of RDX? Huh? None of you heard RDX?
Yes, sir.
Research and development of explosives.
RDX is an explosive. You never heard it?
No,
Huh?
sir.
Very good. You are very innocent. I told you, no, you are all Cerelac babies. Nothing you know about the world except your family and friends. We are
Sir,
good.
bomb na?
Obviously not bomb. This is being used to make bomb. Okay. You are also
Yes, sir.
you people are also academic terrorists. Okay. RDX is called research and development explosive. You will find in different part in our country, these terrorists are using. It is almost looks like our typically used in local area like washing soap. Okay, a small piece of RDX, a small piece of RDX can blow up a huge building. Okay, so this one I have given in your summary. All right, please remember this is not there in our syllabus. না না তারা আগে কালকে তারা দেখলো অন্য মোবাইল, আজকে তো লাইনই নাই, অন্য মোবাইলে করছি ডাউনলোড এখন। Okay, now this next one which I am doing, that is also not in your syllabus. I think the person who has written it, he is very kind to you. The reaction with primary amines. So what is the primary amines? This here, right here. R. So R can be alkyl or it can be aryl. All right. So now what you are going to have? These compounds are stable. So let me write here CH3. I have taken acetaldehyde. Okay. And let me write here this. So what will be the name now? It is called aniline. So what will get here? You will get this, and so these are called imine. These are stable. These are not unsubstituted. Huh? They are. Now, if I do the same reaction with aromatic aldehydes and amine, okay, so what I'm going to get? So if I have done with benzaldehyde, I will get the same thing. I will add here amine, and I'll here add small amount of acid. So these are all acid catalyzed. Okay. So what we'll get now here? You will get here this. This is called benzaldehyde aniline. Okay, or also called benzaldehyde anyl. Now this class of compounds, they're all imine only, but these are also known as Schiff's bases. Schiff's bases. Okay, these are this class of compounds where you have made an imine with aromatic aldehyde and aromatic amines. These are called Schiff's bases. These are again for your entrance exam. So first two reaction I have done for entrance exam. All right. Now I'll go for those reactions which are there in your textbook. I said, please excuse me for 1 minute. Yeah? Okay. Sorry. Huh? So now we'll do unnecessary today. I have lost 20-25 minutes only for technical reasons. Third, but from here you will find these reactions are there in your book. Is the reaction with hydroxylamine. Hydroxyl. How does it look like? See, NH2 is amine and there will be OH. So, hydroxylamine, this is the one. These reactions are very easy. What do you do? Remove water. So, what you are going to get here? Plus, this class of compound are called oxime. Oxime. All right. Now, if you have reacted with aldehyde, those products are called aldoxime. And if you have reacted with ketone, we will call it ketoxime. Say, I have taken here acetaldehyde. Sorry, dear, I have to edit it. So, here, if I have reacted with hydroxylamine, In presence of acid, you get here plus. So this is an aldoxide, but as because we have made it from acetaldehyde, we'll call it acetaldehyde oxide. Okay. Now, if you have done this one with benzaldehyde, we'll call it benzaldehyde oxide. So I'll tell little more here. I'll see the problem with the old people, they talk little more. What is your experience? Hello, Vanchan. Old people talk more or young people talk more? See, I have written the product.
What, sir?
But they may ask you, old people talk more or young people talk more?
Old people, sir.
See, question is that they may ask you in entrance exam, how many isomers are possible? Please remember there are two isomers. They are geometrical isomers. So this is for entrance exam. Okay. So see. Okay. So when I have written here, it's going to form two isomers. See here in this case, the OH group and the phenyl group are opposite to each other. So these type of structures are called NT. Okay. And they're on the same side. So these are called syn. So these are synoxime and these are antioxime. But these days we do not go by syn and anti. We are using that term of E and Z. We know if the groups are on the same side, we call them as Z isomer. And if the groups are on the opposite side, we call them as E isomers. So this is E aldoxime and this is Z. Okay, please, this one only you write. This one you write. Because in this one I did not write in your summary. Is with hydrogen. I'm school student already have done it. So if you have any problem now, so please ask them. There are many other from Miss Aditi is there, then Mainak is there, and then Miss Operator is there, but I do not know what Operator will talk or not. She is saving all her words for future. Okay, so this is called hydrogen. Okay, and this is called hydra. So whenever you react aldehydes and ketones with hydrogen, you will get corresponding hydrogen. So now, if I have reacted this one with acetaldehyde, so I'll get now here acetaldehyde hydrogen. I told you that you should go for group learning. So any problem, you talk to them. All right. You will get this one. This is the acetaldehyde hydrazole. Okay. So now, if you have done with benzaldehyde, you will get here now benzaldehyde hydrazole. Then in advanced school, aldehyde ketone finished. Hello, Miss Rao.
No, we've not done. We've just done haloalkanes from
Very
organic.
good. What I said. So this is the benzaldehyde hydrazole. Now is acetone. So if you have done with this, then you will get now here acetone hydrazole. So these are very easy. Oh, this hydrazine. Hydrazine. And this. So you will get here this. Okay. Now we are going to do the same reaction with another hydrazine. It is called phenyl hydrazine. That is more available in our laboratory. So we are going to use now phenyl hydrazine. Phenyl hydrazine. So what will be the formula here? There will be one phenyl ring. Okay. So there will be one phenyl ring. And we'll call this one to be phenyl hydrazine. And this will be known as phenyl hydrazine. All right. So this will be this. We'll get this. Okay. Similarly, this will be phenyl hydrazine. This will be the phenyl hydrazine. Mind it, dear. If somehow the lab opens for you, in this case, you will be able to use another type of hydrazine to detect the presence of carbonyl group in the lab. So that is not phenyl hydrazine, but it's derivative of phenyl hydrazine. We call 2,4-dinitrophenyl hydrazine. If you take 2,4-dinitrophenyl hydrazine, it is a yellow solution, all right? And in that case, you'll find that it is going to give you a yellow or orange precipitate. So when this yellow or orange precipitate is formed, then you know the compound which is being supplied to you contains either aldehyde or ketones functional group. All right. So anyway, the 2,4-dinitrophenyl hydrogen reaction is not being again not included in your book. Okay. So I'll include here 2,4 dinitrophenyl hydrazine. Okay. In short form, we write as 2,4 DNP. 2,4 DNP. In the lab is always written that 2,4 DNP. Okay. If you ask anyone what is 2,4 DNP, then they become emotional. They cannot say. Okay. Any difficult question is being asked now, you'll find if anyone asks you any question, then you become emotional. Huh? So in that case, teachers are very scared to ask you an emotional question. Huh? Because at this age, if you start crying, who is going to stop you? So you'll get now here. This is called 2,4-dinitro phenyl hydrazine, and this will be called 2,4-dinitro phenyl hydrazone. Okay, it is yellow or orange precipitate. Okay, so in this case, you same way you will get the corresponding precipitate. So you should know. Why you should know this one? You should know because in your practical viva, this question will be asked. They may ask you, what is the 2,4 full form of 2,4-DNP? You will have to say is 2,4-dinitrophenyl hydrazine. Then immediately teacher will ask, can you write the structure? You will write it. Okay. Then if they ask you, please write one equation and write the name of the product. In that case, suppose you are being given benzaldehyde. You will write the product just like this. Okay. Benzaldehyde one, phenyldehyde one, hydrogen will be here, and you write the name of the product is 2 benzaldehyde 2,4-dinitrophenyl hydrazone. Benzaldehyde 2,4-dinitrophenyl hydrazone. All right. Now I'll come to the last one of this one. It is called reaction with semi carbazide. Okay, semi carbazide. What is semi carbazide? This is called semi carbazide. All right. This question sometimes comes. So if you have taken this, what is going to happen? This will go. This is called semi carbazide. And you will get here the product will be known as semi carbazone. Semi carbazone. Okay. So accordingly, you can react with an aldehyde to get aldehyde semi carbazone product. If you do with the ketone, that would be semi carbazone. Okay. But in CBSE, sometimes the question may be asked. I don't know about emboss. I told you no, emboss is a harmless board. Emboss follows the principle of non-violence laid down by Mahatma Gandhi. See, in CBSE, the question may ask, why this NH2 reacts? Why this does not react? See, here also you have NH2 and here you have also NH2. Why this NH2 attached to nitrogen is attacking? Why not with the carbonyl group? What is the answer now? See, carbonyl group is an electron group. Yeah, it is an electron withdrawing group. Okay. In this case, what is going to happen? Carbonyl group is going to pull electron towards oxygen. See what is going to happen now. It will pull. So what you are going to get ultimately? NH2, NH3, O minus, NH2 plus. See, now the electron is missing. So it decreases the density of electron on the nitrogen. Because of that, it does not act as a nucleophile, but this acts as a nucleophile because it is far away from the carbonyl group. Please remember. So with this, I finish the addition elimination reaction. Addition elimination reaction. Okay. Now again I tell you the summary of it. We find when the carbonyl group aldehydes and ketones are reacted with nitrogenous nucleophile, that is ammonia or its derivative, it undergoes addition reaction, but the addition product is not stable, immediately undergo elimination of a molecule of water, leading to the formation of carbon-nitrogen double bond. Hence, these reactions are called addition-elimination reaction. Clear? So, you can carry out this reaction with ammonia. You can carry the reaction with primary amines. You can carry out the reaction. If you react with ammonia or primary amines, the products are called imine. And if you carry out the reaction with aromatic aldehydes or ketones with aromatic amines, those amines are called, these amines are called Schiff's bases. Okay. Anyway, both these reactions are not being included in your textbook. If you react with hydroxylamine, you get a class of compounds, we call it oxime. If you get the product with aldehyde, we'll call it aldoxime. If you get the product with ketone, we'll call it ketoxime. Now, if you similarly, if you have used hydrazine, you get hydrazone derivative. If you have used phenylhydrazine, the products are called phenylhydrazone. If you in a laboratory we are using 2,4-dinitrophenylhydrazine, so those products are called 2,4-dinitrophenylhydrazone. Okay, all these things I have written in your summary. Clear? And similarly, if you carry out the reaction with semi-carbazide, then it results into the formation of corresponding semi-carbazide. All right. Now see, we have already classified